Hello, everyone. I am Kenny Coogan, the CFI Center for Inquiry Education Coordinator, and thank you for joining us on another exciting webinar. We have one or two a month, and today we have Adam Scaife, who's going to be talking about his new book, The Little Book of Weather. And I have them right here. They're little, but the text is little, which means they are jam-packed with information and facts. We're excited to hear Adam's presentation, and if you're attending this live, you have a good chance of winning a copy of his book, thanks to Princeton University Press. And you stick to the end to find out if you're the winner. And also, if you're attending with a class, feel free to type in questions into the chat box, and I will read the best questions to Adam at the end of his short presentation. And thank you, Adam, for agreeing to this, and we're looking forward to your presentation.
Okay, thanks very much, Kenny, and thanks for inviting me to talk about the book. Hello, everybody. Thank you for coming. I'm going to talk for maybe 10 or 15 minutes, and then I think Kenny has a few questions, and I encourage you to jot down your questions, whether they're about the book or about meteorology or climate. I'll be very happy to discuss any of those topics with you afterwards. So as Kenny says, this is a new book. It's called The Little Book of Weather. I wrote it over a period of about a year to 18 months for Princeton University Press. And I guess this summary headline here is how I feel about it. It really is a kind of celebration of one of the topics in science, which although quite prominent in the media with climate change and extreme weather events and so on, is perhaps rather unsung in science teaching and science classes as one of the real triumphs of science. And by that I mean that weather and climate science are one of the real triumphs of applied science. We can now make forecasts, we understand global connections. There is so much there in the scientific literature now. So in that sense, I feel it's a real triumph of science. And I've tried to show that in the book. So we start from some basic physics in the early chapters, and then we expand into all sorts of subsidiary connections and topics. So there's bits of chemistry in the book, there's bits of biology, there's connections to geography, and regional physical geography, for example, appears in many places. And there are even sections on things like myths and folklore and history. And I'll talk about those a bit more in a minute. So yeah, it really is a kind of collection of everything, a kind of brain dump from my knowledge. I've been in the field a long time, and we've tried to show all the interesting stuff. So if you read the book, you'll know how everything from rainbows to climate change works, even how weather on other planets compares to that on the Earth, and even going back into very remote history of the Earth and how the weather we think has changed over very long time scales. As Kenny says, it's part of it's published by Princeton University Press. It's actually part of a series, so there's a whole set of these, not all written by me. They're each written by a different expert. You can see a list of some of the recent titles there. And they come in kind of nice pocket-sized format. I mean, one thing I was very pleased about is the way that Princeton University Press has bound and illustrated it, actually. It's a very nice thing. I'll tell you a bit about me, a bit about my background. I live and work in England, in the UK. I grew up in the north of England. I don't know how well you know regional UK geography, but there are some industrial cities in the north, so I grew up in an industrial city. My parents did not go to university. They are not scientists. They had very regular jobs. My dad was a factory worker, for example. But I've always thought that science and math are absolutely amazing. I was fascinated from a very young age. And this line here perhaps encapsulates my view of science and math, or maths as I would normally say, which I see that those things and their predictive power and the insights they provide are more amazing than any fiction book I've ever read. And I've tried again to bring some of that enthusiasm out in the book with all the eclectic topics that are in there. I suppose a bit more about me. I kind of have a strong view, coming from kind of a modest background, that education and science should be equally available to all. So I hope this book helps in some tiny way to achieve that. My own education, I studied physics at Cambridge in the UK. I have a master's degree from Surrey and a PhD in meteorology from Reading University. So that's my educational background. And that was all, up until the Reading stage, was all physics and maths. And it was only really at a late stage that I got into weather and weather forecasting. And I'm now head of long-range forecasting at the UK Met Office. That's like the National Weather Service, and also professor at UK University in Exeter. So that's me. The book covers a very broad range of topics, as I say. This is the first half of the contents. These pictures, by the way, are just snapshots I took with my mobile. They don't really do the book justice. But anyway, you can see my snapshot there on the left of the first 6 chapters. There are 12 chapters in all, 6 sections in each chapter, so 72 in all. I've tried to make, I think I'm well known, at least regionally here, for writing in very clear and simple language. A colleague actually told me the other week about one of my recent papers that my science papers are a bit like a story. They're nice and clear and easy to read. And I hope that's true of these little sections. And they're all kind of freestanding, actually. So you can dip in and out as you please and read each chapter or even the subsections individually. And so you can, do 5-minute readings and chop and change. I also drew many of the simple diagrams, and I'll show you some examples in a moment, to try and convey the meaning and the science and the mechanism behind these things. Princeton University Press have been very good, actually. They gave me a complete free rein. So this really is eclectic. It covers all the usual topics, rainbows, rainfalls, cloud, and so on, but also a lot of other stuff, as you can see from some of these other chapters here. And just to give you a taste for that, the picture of Jupiter there in the middle is to illustrate the fact that there are sections about weather on other planets. And the picture at the bottom are some ancient creatures from the Cambrian period and the Cambrian explosion in life and evolution. And there's even a section about the changes in the atmosphere that occurred in that period. Everything I've put in the book is completely solid in terms of science. If I speculate, I say I'm speculating. There's a section on the future, chapter 12, where there's a few possible ideas about the way things are going, but everything else is backed up by solid peer-reviewed science, and there's a glossary and index and so on. So I can provide you with peer-reviewed reference for everything in the book. Some of the obvious things that are in there, it obviously covers all the major topics and aspects of weather and climate, everything from forecasts and the history of forecasting through to where we are now. There are chapters on some of the deeper concepts in that, things like chaos and the unpredictability of weather and climate. You may know Ed Lorenz, who was an American scientist working at MIT, famously discovered chaos and the fact that a small perturbation now can lead to big changes later on by modeling the weather. And all this stuff is in the book. And then there's the more usual topics, the more expected topics of things like extreme weather, sunsets and radiative physics, right down to common things like cloud types. And another aspect in the book, in some of the chapters, is climate change, of course. So we've tried to cover both weather and climate, not just weather. And I've tried to outline the main features of climate change. Some of the more kind of eclectic sections include something on myths and folklore. So I suggested this to the publishers, and they thought that would be of great appeal. So I collected together a bunch of topics, bunch of common myths from around the world, not just in the Western world actually, but from all over the place, and carefully examined those and debunked lots of them. For example, this one here, the the bathtubs and plug holes, you may be aware that there is this myth that if you're near the equator and you empty the bath, or you take a bucket with a hole in it and let the water out, that it will rotate one way in the northern hemisphere and the other way in the southern hemisphere due to the rotation of the Earth. Well, unfortunately, although the physics is kind of right about that, there is that effect, and in principle it would happen. In practice, it doesn't. The residual spin of the water in the bathtub actually determines it, and anyone who shows that with a bucket and matchsticks has given it a bit of a stir, because actually the effect decreases to zero at the equator and is much bigger at the poles, for one thing. So that's one example of a bit of myth busting. But others do have a grain of truth. And so I've tried to be very even-handed. And above all, I would say that the approach in that chapter is rational and scientific. So it's quite fun to look at these things with a scientific eye. I also have a number of sections in there on kind of deeper weather and climate science. And I've tried to bring out the things that really excite me, that I'm really enthusiastic about. And this is just one example here of one of the sections. It's this thing called the quasi-biennial oscillation. And that sounds a bit of a mouthful, but as the name suggests, it's simply an oscillation that occurs with a roughly 2-year timescale. It's shown in that picture, actually, the colored picture on the left. What happens here is westerly and easterly winds propagate down through the atmosphere over very long timescales, something that you really wouldn't expect through first principles. This is much less noisy and chaotic than the weather systems that we're used to. This occurs high over the equator in the lower stratosphere, but a fascinating phenomenon discovered by American and British scientists in the late 1950s. And I would argue it's the most regular thing in the atmosphere after the annual cycle of the season. So that's just one taste of some of the deeper things that also appear in the book. I think one of the things that stands out about Little Book of Weather are the illustrations, and my snapshots here really don't do them justice. There are some beautifully hand-painted illustrations, like the one in the background there of the ice crystals, that were commissioned specially for the book by Princeton University Press. So every so often you get a full-page artwork, and then in almost every section there are additional pictures like the ones that I've got inset there, which I drew first versions of, and then they were produced by the publishers to really extract the bare bones of the mechanism of what's going on and really get across the science to the reader, so that you should come out understanding exactly why the sky is blue, why the sunset is red, why the polar vortex warms when the winds collapse, and so on. And then coming to some of the more diverse chapters, there's a whole chapter about weather and historical events. And here I've picked some really interesting key turning points in history, points at which, I'm no historian, but these are points at which the historians agree things were on a knife edge and could have gone either way. And there were key events related to the weather that pushed history one way or the other. And one of them is shown here. This is the Nazi Germany invasion of the Soviet Union during the Second World War, which was hampered by weather and led to them getting very close to taking Moscow, but not quite. Just one example, and there are a number of others, including Napoleon's earlier, a century earlier, attempt to do the same thing. So those are some examples of how the weather has really influenced human history through its impact on our endeavors and hindering things like that campaign in the Second World War. So there's a whole chapter about history. That also includes some American history, and one of the events that's included is the 1930s Dust Bowl that you may know had an enormous impact on the economy and the livelihoods and the agriculture in the Midwest of the USA. A terrible, persistent drought and change in the weather in that time in the 1930s. Complete change in the regional economy. Really terrible hardship. You may know the famous John Steinbeck book, The Grapes of Wrath, which was written about that period. And I'll give you some hints in there and some in the book and some discussion about the latest science about that event and how we now understand it was related to changes in the ocean, actually, either side of the North American continent. I'm not going to talk for much longer, but I couldn't talk about the book without mentioning the fact that we do cover the big issues of our day. Obviously, it talks about climate change. I give a very level-headed view of that. We also tackle some even more controversial topics like geoengineering, where people are suggesting to intervene and try to use artificial methods to reduce climate change, for example, by injecting reflective particles in the upper atmosphere. So all of that is dealt with in a very level-headed manner, obviously exposing the issues as well as the benefits. So I hope when people look back at this in years to come, they will see that it is a very straightforward and accurate account of the pros and cons of those things. So in summary, I hope you find the book entertaining above all. There is this massively broad range of eclectic things, and the things that have really excited me that I've come across over 30 odd years in the field. There are lots of different sections, so you can dip into any order. And my real aim with this book is to stimulate people to look deeper into the science in a very level-headed manner, a very rational and scientific way. And if you do spot any errors in edition 1, then do drop me an email. And if we publish edition 2, I'll be sure to credit you. And I will stop there, and I look forward to your questions.
Okay, thank you so much, Adam, for that.
Thanks.
Okay, if you stop sharing, yeah, that's...
Yep, done.
Okay, perfect. So I'm going to read a couple of comments for people who are watching this as a recording, so they know what we're talking about. Helen says, thank you, Adam. This book sounds like a great resource for my geoscience class, 9th grade primarily, but 10th to 12th grade class. It would be a great way to integrate many of the things in this book. And why should students consider a career in meteorology? Is it an exciting career? Okay,
that's a good question. I mean, when I was a kid, it was not something I wanted to particularly do. I wasn't one of those kids that goes out with a thermometer and a rain gauge every day and recorded the weather in their back garden. That wasn't me. Actually, I was more interested in bugs and maths and different topics. All science, though. But to answer your question, I came to this through physics and maths education, as I mentioned. But people do come in from different areas. So you get people who are more interested in things like the biological impact of climate change. So you get biologists. There are chemists working in this field who look at atmospheric chemistry, not least things like the ozone hole, which is also in the book. We talk about the basics of that. So all of these different interdisciplinary aspects come together in meteorology. And that is also related to the fact that there are a massive array of impacts of weather and climate, especially with climate change. And so if you want to get funded as a researcher, there is probably no better topic at the moment than climate change in terms of the amount of funding. The number of PhD students I have has risen year on year. The amount of funding for these topics is becoming more and more important. It is the problem, one of the big problems of our time, and it is going to get worse. So in terms of weather forecasting, we have to predict more and more extreme events. In terms of climate change, there is an accelerating increase in the number of extremes and an accelerating increase in the impacts. And it goes right through to everything, down to, if you want to be an engineer now, you have to design buildings to take these things into account. You'd be stupid not to. Storm drains, for example, in the UK are Victorian. They're not equipped to cope with these things. There are so many things to do that actually moving into meteorology is going to be a major thing in the future. We need lots of lots of insights into these things and quantifying how things are going to impact society in all those different ways. Sorry, that's rather a long answer, but I hope you get the picture.
Yeah, that was great. And that was a good segue because you talked about the interdisciplinary aspect. And
Yes.
Bertha asks, what type of background should a student have prior to university if they want to study weather and meteorology?
I think if you want to, it depends where you want to end up, but if you want to do scientific research in meteorology and climate, I think probably the top two subjects are physics and maths. That's not to say that's the only route in, but I would say those are the top two. And then there are other subjects like environmental science, chemistry, physical geography, other things that are also relevant, but probably the top two are physics and maths.
I work for International Carnivorous Plant Organization, and they look at weather patterns to predict where those plants can live in the future as water levels rise or weather patterns change. So it benefits biological people too.
Yeah, I mean, there are now measurable changes in species distributions already. In the UK, we're kind of separate from the continental Europe, and there are migrants that come across the English Channel. There are many well-documented cases where those things are increasing due to the warming temperature. Yeah.
Before we started recording, I shared with you that I've gone through some horrible tropical storms and hurricanes this year.
Right.
Can you tell the watchers what is a 100-year event, like a 300-year event? What does that mean? And what does it mean if my city pumps can only handle a 10-year flood event?
Yeah. Okay, so the key thing here is the engineering tolerance and the 1 in 10 that you talk about, and then the fact that you've had 1 in 100 or perhaps even more extreme events in recent years. The key thing here is that because we're not in a stationary climate, that the climate is trending, and for many years, the computer models that we use to predict climate have indicated that tropical storms and hurricanes are going to get more intense. In addition to the strengthening of the storms, the warming of the atmosphere means that the warm atmosphere holds more moisture, and therefore when that moisture does come out, you get more intense rainfall. So even for the same strength storm, you can get more rainfall. This all means that what was 1 in a 500-year storm is becoming more frequent, and so those probabilities of the intensity is changing. And so if the what was classified as a 1 in 100 was based on old stats and old climatology, that is going to become 1 in 10, and so the whole thing is sliding down the scale. In the UK, we've had unprecedented events that were not feasible without climate change. And so the shift in these probabilities is occurring so quickly that we need to adapt quickly, and we need to change infrastructure and make people prepare so that they are aware of what's coming. And it's particularly in the extremes. For those that have a mathematical bent, if you plot a Gaussian distribution and you say that is the distribution of storm strengths, for example, and then you move that Gaussian to the right. Sorry, I'm kind of inverted on the thing, but if you move it to the right, and then look at what happens in the tails of the distribution at the really extreme events, then they go up proportionally faster because they're in the extremes. The curvature of the tail of the distribution means that even for a linear increase in temperature, you're going to get a non-linear increase in the frequency of extremes, and it's that we need to prepare for.
And earlier you mentioned about chaos theory, and then I heard that
Yeah.
as the environment or water or air get hotter, there's more chaos.
Yeah, I mean that is something that people say. Uh, I think we have to. Yeah,
You
I mean the
you
chaos
can
that
you
I
can
mean.
debunk it.
Yeah, okay. I'm going to debunk that, Kenny, if you don't mind. You can see I'm
I
slightly
was just
uncomfortable with that
saying
one.
what I've heard.
Yeah, I know. I've heard lots of people say that. I mean, the chaos that I'm talking about is the strict mathematical definition of chaos. That if I take a computer model of the atmosphere and I make a small change in one part of the world, then over a period of a few weeks, that change can change the global evolution of the weather and result in a massive difference. It could mean that there is a hurricane or no hurricane. And that is not just a myth. It's not just a kind of joke or a game. That is actually a property of the underlying equations that govern the weather. And so the idea of chaos is a real idea, and it limits how we can make forecasts because it means that they're going to diverge due to inevitable errors in how we start the forecast off. Having said all that, I think that that property and the amount of chaos is probably fairly stationary with time. And it doesn't stop you making very long range predictions because all we do is we make lots and lots of forecasts and look at whether they're all trending in the same way or not, even though the differences between individual forecasts is hard to predict.
Okay, we have a couple more questions, but first I want to
Yeah,
announce
sure.
the two lucky winners. Princeton Press University sent us a handful of books. We're going to give away two today, but then the rest are going to be given away at our live in-person workshops that we do all around the United States. And we're filming this in 2024. And since 2015, we have presented over 370 in-person workshops. So if you are a science teacher, let us know about your state conferences or your district conferences, and we would love to come and present. And for Center for Inquiry's educational programs, which include TIES, the Teacher Institute for Evolutionary Science, Science Saves, and Generation Skeptics, all of our resources are free. All right, so the two lucky winners are Helen H. and Marianne. So if you guys want to send me your shipping address privately, I will get those books sent out to you. So Adam, obviously hurricanes, tropical storms are horrible, but Demi asks, what is your favorite type of weather to experience? As a gardener, I love a gentle rain.
Yeah, I quite like gentle rain I'm actually a fisherman, so I like that too. I guess I'm going to have to say snow, though. We get very little snow nowadays in the UK. We had a little bit the other day, actually. Unfortunately, we're absolutely rubbish at responding to it, so everything stops. But I like snow, yeah, which is becoming rarer, unfortunately. Yeah.
So, like I mentioned, Center for Inquiry has three educational programs, and you're presenting for TIES, but also for Generation Skeptics. Can you talk a bit about why are people so not upset, but why are there climate change deniers? Why is this like
Yeah,
a hill that they want to die on?
yeah, it's strange, isn't it?
Or
I
why
must
are they
admit, I don't.
confused? Why are they confused
Yeah,
that humans can have an influence on the climate?
right. Okay, I mean that's a slightly different question. I think I can probably have a better shot at answering that. I think it's tempting to think that the globe is a very big place. It has enormous mass. Um, it is impervious to our influences and will continue to behave in its own way, whatever we do. I mean, that is a kind of naive, obvious thing that I guess some people still believe. But when you look at it scientifically, you can see that although that's obviously true about the Earth's path around the sun and its rotation and so on, what is not the case is that the atmosphere is impervious. The atmosphere is but a thin skin, a tiny thin skin around the Earth. I'm sure you've all seen the pictures from space. The mass of the atmosphere is many orders of magnitude smaller than the mass of the Earth. And when you do the calculations and you look at how, for example, CO2 has changed since the Industrial Revolution, then we've gone from maybe 200 to 50 parts per million up to over 400. That is a big percentage change in the CO2. Now, the CO2 is only a small constituent, and a skeptic would say, what does that matter? But if you go back to the time of Joseph Fourier, the famous mathematician, even at that time, people had been calculating and estimating the impacts of gases like CO2 on the absorption of infrared radiation. And the famous chemist, the Swedish chemist Svante Arrhenius, who we all learn about in chemistry classes for the Arrhenius rate equation, for the rate of chemical reactions, he actually sat down in 1896, wrote a paper demonstrating that increasing the CO2 by a substantial amount would lead to a change in atmospheric temperatures near the surface of about 5 Kelvin, 5 degrees C, whatever that is in Fahrenheit, maybe 8 or 9 Fahrenheit. So even that at that time, more than a century ago, the basic knowledge of science was able to tell you that if you load up doubling or so of CO2, a big increase in the CO2, despite its small fractional contribution to the atmospheric constituents, would still likely have a punch well above its weight in terms of its radiative properties and warm the surface. So I think there's not that much to explain and not that much to understand in order to reach this conclusion. If people could do it 100 years ago, why on earth can't they do it now? I'm mystified. And the computer models that people have written in all meteorological centers, when you do the calculations, you put in increase in greenhouse gases, every model that is worth its salt produces global warming. There is no argument.
Okay, Adam, we have 2 more questions. Josh asks, what was your favorite subject to research and write about in this book?
Yeah, I mean, I had a number, so it's pretty hard to pick, actually. I picked a lot of my favorite topics and put them in here, but something I've got interested in a few years ago is a slightly forgotten topic about the relationship between the spin of the atmosphere and the spin of the Earth. Now, because the atmosphere and the Earth are floating in space, they're isolated to all reasonable approximation. And that means that the angular momentum or the spin has to be conserved. And that means that if the winds get a bit stronger, then the Earth has to spin ever so slightly slower. And so the day length changes. And this is actually measurable. It's remarkable. Astronomers have been looking at very distant stars and measuring how they pan across the sky. And you can measure down to tiny, tiny fractions of a second the length of the day doing this. And so there is this balance between the wind and tiny changes in the rotation period of the Earth. And I showed in some of my research work that this actually has an impact on that there are some interesting impacts on the atmosphere. So I wrote a bit about that, and I talked a bit in one of the sections about how the moon is slowly moving away from the Earth, and this also changes the rotation rate of the Earth. And if you wind history backwards and you put the Earth closer to bring the moon back towards the Earth, then the day length would be much shorter. And you would not believe how much shorter, but you can work this out with a pencil and paper. I've done it. It turns out that if you go back 2 billion years, maybe 3 billion years, the moon was very close to the Earth, and the day length was about 6 hours. I mean, what a bizarre and remarkable thing that is. I mean, that just tickles me. I think it's amazing. You know, what was going on when we had 6-hour days and the moon was so close? We must have had enormous tides. This was at the time as well when the oceans and the earth was kind of reasonably well formed, not that far from the sort of, we're talking billions of years ago, but maybe close. The impacts of all these things on the evolution of early life as well a bit later on. Anyway, I think that topic's fascinating, and of course is not that well understood because it's so old. But Newton's laws and physics tells you that this must be true. And that's kind of the power of science that delights me. So I put a bit in that in the book. Yeah.
Very good. Now, you mentioned that it took you 12 to 18 months to write this book. And
it did.
Helen, one of the teachers who won your book, asks, now you have completed this book. What is next? What are your next goals and projects?
Okay. I mean, I did this in my spare time. As I say, I have a job here at the UK Met Office where I head up the research and production of long-range forecasts. So that's my main day-to-day, my regular job. And then I also have a part-time position at the university, so I supervise students and things. But I do plan to hopefully write another book. It's a book about waves, and I'm particularly interested in what happens when waves have been and gone. Lots of people have written about waves in different contexts, but waves carry momentum and they carry energy. And when the wave breaks or dissipates, it has subsequent impacts. And there are all sorts of interesting connections with other phenomena. For example, the solar corona and longshore drift along the beach is actually the same process. So I might try and finish what I've started a book on that. But I must admit, this book was written. I used to get up at 8 a.m., write an hour, and then go to work. And first thing in the morning, I was doing an hour a day, and then Sunday afternoons were a bit of a pain. So it's doing it in the margins. So never that easy. Maybe, yeah. So yeah, but I do hope to write another book. And I'm kind of interested in various topics in my research. So that is kind of what gets me up in the morning. And we just published a paper in the American journal Science, actually, about how El Nino affects climate a whole year later after it's been and gone, which is really unexpected. So it's those things that really kind of excite me, and I hope to do some more of those. Yeah.
So thank you, Adam Scaife, for talking about your little book of weather. And in here, you also talked about El Nino and La Nina.
Indeed, yeah.
So we encourage everyone to check out the book. And thank you, everyone who attended this presentation live. Thank you, Adam.
Thanks a lot. Great talking to you. Bye-bye.